Unit 7, we took a look at taking the nth root of a positive number, and we said based off that nth root there were either two real solutions or one real solution. Well, today we're going to take a look at powers and roots of negative numbers. So remember our notation here for this nth root. The nth root of x, when x is negative now and n is an odd integer, the nth root of x represents the real nth root of x. Now, when we're taking the nth root of x and x is negative and n is an even integer, greater than or equal to 2, then the nth root of x is undefined. All right, now remember this number would be like taking the fourth root or the square root or the sixth root of a negative number, and we say that's going to be undefined. All right, now the nth root of a product, remember we can take that nth root of that product and break it up into the nth root of x times the nth root of y. These are going to be some tools that we're going to use as we go throughout our examples today. So in example 1, we're wanting to calculate negative 4 to the power of x when x takes on the values of negative 3 to positive 3. It says which values are positive and which values are negative. So let's start in by taking negative 4 to the negative 3 power. Now that means we got to take the reciprocal of that base, that's 1 over negative 4, to the positive third power. So that's going to be 1 over negative 64. And we take negative 4 to the negative 2, that's going to be 1 over negative 4 to the second power, which is 1 over positive 16. Now we'll take negative 4 to the negative 1, and that's just simply going to be 1 over negative 4, which is negative 1/4. Negative 4 now to the 0, anything raised to the 0 power is simply 1. And now let's go negative 4 to the first power, and that will result in negative 4. Negative 4 squared is negative 4 times negative 4, which is 16. And finally, negative 4 to the positive third power is going to result in negative 64. So what you're seeing here, the pattern that you're seeing, is that only when our odd powers are negative do we actually get a result that is negative as well. When our powers are even, we are going to end up with positive values. All right. Example 2 says you got a little bit of multiple choice. Now tell which of the following describes the expression. Is it defined a real positive number? Is it defined non-real? Is it defined in a real negative number? Or is it not defined? So here we're taking the cube root of a negative 20. Now because our root is an odd number and this is negative, we know that there will be one real solution, and that one real solution is going to be negative. So if we're looking at our choices here across the top, we are going to select B. B is defined and it's a real negative number. All right, our next one, number 2, we have the sixth root of negative 64. So we're taking an even root of a negative number, and now we know that this is an undefined term. Next is a square root of 63, and this is an even root, but it's a positive number. And when we take an even root of a positive number, we are going to end up with a positive real number solution. So this is going to be A. It's positive, and it's a real number. And finally, we have to take the square root of a negative 14. Again, we have an even root that we're taking because it's a square root, and it's the negative number, so we say that this must be undefined as well. All right, example 3 now. Again, we're going to evaluate each of these as a single power without exponents. So we have negative 5 raised to the negative 4, negative 5 raised to the 7. Remember, when we have the same base and we're multiplying, we're going to add our exponents. So this is really negative 5 to the negative 4 plus 7, and that results in negative 5 to the positive 3, which is negative 125. Now, since negative 5 to the positive 3 is negative 125, then we can take the inverse operation and go the other way. We'll say the cube root of negative 125, therefore, must be equal to negative 5. Also, because negative 100,000 is negative 10 to the fifth power, then we can say the fifth root of negative 100,000 is negative 10. All right, so that's just kind of getting you familiarized there a little bit with those inverse operations. Now let's see how we can apply this when we're simplifying some radicals. All right, our first one says we're going to take the cube root of negative 1,250. Well, negative 1250 or negative 1,250 is not a perfect cube, but we can factor it into two perfect cubes. This can be the cube root of negative 125 times 10, which is equal to the cube root of negative 125 times the cube root of 10, and that's negative 5 times the cube root of 10. So our final simplification here is negative 5 times the cube root of 10. All right, example B here, we are taking the fourth root of 48 n to the 15th. Now again, 48 is not a perfect fourth root, but we can take a factor out of that. So we're going to factor that 48 as the fourth root of 16 times the fourth root of 3. Now likewise, we're going to take this n to the 15th and factor that into two roots as well, and one of those will be a perfect fourth root. We'll take the fourth root of n to the 12 times the fourth root of n to the remaining amount, which will be the third power. All right, now the fourth root of 16 we can simplify to 2, and the fourth root of n to the 12th simplifies to n to the third. However, the remaining two, the fourth root of 3 and the fourth root of n cubed, need to come back together under the radical, and that will be the fourth root of 3n to the third power. So when we're done, our final simplification form there is 2n cubed times the fourth root of 3n cubed. All right, example C now, we're taking this cube root of negative 27, which we can do, and a to the 12th. So the cube root of negative 27 is negative 3, and the cube root of a to the 12th, remember, we can rewrite that as a to the 12 thirds, which is simply a to the 4th. So the cube root of negative 27 a to the 12th simplifies to negative 3 a to the 4th. All right, example D here. So we're going to take the fifth root of 512 x to the 12th, y to the 20, z to the 9th. This is a doozy, so bear with me. Here we go. We're going to take factors out of 5,120, and the two factors are the factor of 32. So we're going to take the fifth root of 32 and times that by the fifth root of 160. All right, now next we're going to take this x to the 12th, and that factors into the fifth root of x to the 10th times the fifth root of x squared. Next is y to the 20th, and that's the fifth root of y to the 20th. And finally, we have the fifth root of y to, what is that? The fifth times the fifth root of y to the 4th. Now, if you're wondering why I broke those all down here, it's because these ones that I'm circling are all perfect fifth roots. So these guys can be simplified, and the remaining ones will be written back under that radical. So here we go, let's simplify this. The fifth root of 32 is 2. The fifth root of x to the 10th is x squared. The fifth root of y to the 20th is y to the 4th. And the fifth root of y to the 5th, oops, I'm sorry, that should be, this should be z here. Let me go back and change this. This is no longer y, this should be z. And maybe threw you off on that a little bit. So we got the fifth root of z to the 5th should be just z. All right, now we've simplified all of the ones that were circled. Now the ones that we're underlining need to all go back under that radical of the fifth root. So we're going to rewrite that as the fifth root of the remaining amount, which is 160 x squared z to the 4th. All right, I told you that was going to be a doozy. The last two examples for today, here we have the fifth root of negative 32. This is going to simplify to negative 2, plus the fourth root of 16 is positive 2, and that's 0. Seems a lot easier than the previous one, doesn't it? All right, Now, letter F, we got the cube root of negative 125 x to the 9th over 27. So if we just break this down by our numerator and denominator, let's take the cube root of negative 125 x to the 9th, divide that by the cube root of 27, and that's going to result in negative 5x cubed all over 3.